We're going to go into 3.2, which deals with polynomial functions and their graphs. You're not going to need a calculator if you understand the shortcuts to it. But for right now, you have a calculator so you can actually see what it does, but you'll be able to do it without. So we're going to deal with polynomial functions. When you think of exponents, what kind of numbers are the exponents on your equations? Are they decimals? Mostly they're always whole numbers. Are they positive or negative? Positive. So a polynomial must have a positive whole number for their exponent. So for example, you have seen x to the 5th, maybe x to the 20th, maybe you just see an x because the power of x is just what? A 1. So this is a positive whole number, so it still works. So next thing we're going to be talking about is the leading exponent. The leading exponent, that means the first exponent you're going to see when it's written in order from largest exponent to the smallest, that is called your degree. Now, this degree has nothing to do with the degrees that you guys covered in geometry.
Did it work?
Yeah.
Okay, all right.
Degree is, we're just talking about exponents. That's it. So if I were to give you the problem, x minus x squared plus 3x to the 4th plus 1, what do you think your degree for that problem would be? 4? Why 4? What did you do to that? Is this in order from greatest exponent to the smallest? No. So the first one should be 3x to the 4th minus x squared plus x plus 1. So once they're in order, who's your largest exponent? 4. So yes, you are right. My degree is 4. Questions right there. So this is just part of the notes of information you're supposed to know already. Supposed to, but if you don't, it's okay. The last thing is non-polynomial. So the opposite of the first two thingies. Non-polynomial functions have negative. Oops, I misspelled negative. Numbers or fractions as exponents. So for example, you can have x to the negative 2 power. That's not allowed. Or even if I had something like this, the cube root of x. The cube root of x is having x to the power of 1/3. That 1/3 is not allowed. So no fractions, no negative numbers are allowed when you are doing the, when we're dealing with polynomials. Questions up to right now? So that's just information. So in example 1, example 1 is going to help you answer number 1 and 2 of your worksheet. It's determine if the function is a polynomial or not, and the degree. So we're going to do 3 problems together. So determine if the function is a polynomial or not, and the degree. So let's look at the first one. Let's say they give you something like this, and I'll stop right after I write down the problem to make sure everybody's ready. So is everybody done writing? Caught up somewhat so far? Start looking at the exponents. Are they in order?
Yes.
Yes. Are all your exponents whole numbers? Yes. So when they ask the question, determine if it's a function, if the polynomial is a function or not, the answer is yes. Now, what is the degree?
5.
The degree is 5. And that's how simple it's going to be. Now, some of them, well, for some, right? Then, of course, we run into something else. Let's say you had this problem. X to the 8th power plus 7 over x to the 3rd. So when you look at this problem, I just see what kind of exponents. Positive, right? I see an 8 and a 3. But please remember, this is the same thing as having x to the 8th over x to the 3rd plus 7 over x to the 3rd. Now, what happens in the first part of the fraction? X to the 8th over x to the 3rd becomes what? To the 5th, right? Because we've learned that when you have exponents in division, you subtract them. Is everybody okay with that? But in this section, exponents are not supposed to be in the bottom. If I were to move it up, it turns to a negative. Very good. So this becomes, and I don't know why I put that, but it should be plus 7x to the negative 3. So when I look at that problem, is that a polynomial? No. So the answer is just going to be no, and you're done. When the answer is no, it's just not a polynomial, and you don't have to figure out the degree or anything. Yes, so as soon as you have that, yes.
Awesome.
Now, please be careful, because if you would have had like 8 over x to the negative 2, it becomes positive because you need to move it. I don't want for you to say, oh, it's negative. She said it's a no, because that would move up and it would become a yes. Yes.
So like if it's 8 to the 5th, then over x to the negative 2.
So 8x to the 5th over x to the negative 2, that would become 8x to the 7th. So it's still a yes. Because when you move up the negative 2, it becomes a positive. Yeah. All right, this is the last one we're doing in this section. Let's say you had this problem. It's not going to happen on your worksheet, but it may happen on your test. So this is why we're going over an example like C. So let's say they give you this. Can I figure out what my polynomial is right now?
Mm-hmm.
Yes?
Yes.
How? By doing what?
The x minus 2 and x plus 3, you have to take off.
Okay, so I have to do some work. So I have to do FOIL between the first two, right? So what is x times x? X squared. So let me work this out. Oh, and I don't know why I put a negative. Got beat out. Sorry. So it is x squared. X times 3.
3x.
3x. Negative 2 times x.
Negative 2x.
And then negative 2 times 3.
Negative 6.
Negative 6. We could combine. And that's what happens. Am I still done? Nope. I still need to distribute this to all three of those. So what is negative 3x to the 4th times x squared? To the 6th. Please remember, when you multiply, you add exponents. So it becomes to the 6th. Negative 3x to the 4th times x to the 5th. And the negative 3x to the 4th times the negative 6 becomes a 18x to the 4th. Are they in order?
No.
Yes, they are. Because remember, it's by exponents, not the numbers. Is it a polynomial?
Yes.
Yes. Who's my greatest exponent? My degree is 6. So once again, this is your problems 1 and 2 from your worksheet. 1 and 2 from your worksheet. Questions? No? Alrighty. I am gonna, the next part is notes. Some little things you need to know. We're gonna be talking about end behaviors. So questions 3 and 4 deals with understanding the end behaviors of polynomials. So this is what happens. If n, and n we're talking about your exponent, is odd, and we all know what odd numbers look like, right? 1, 3, 5, 7, 9, and so on. And if there's two situations, your leading coefficients
Just an end.
and if, yes, sorry. From now on, for leading coefficient, I'm just going to put LC, just so you know. So, and if your leading coefficient is positive, then the graph, and I'm going to end up doing a little sketch of a graph over here. Then your graph falls to the left, rises to the right. And I know this information just sounds weird. So falls to the left, rises to the right. Falls to the left, rises to the right. So if we see a graph, what does falls to the left and rises to the right mean? Well, I have a graph who's going to be going down on the left, and it's going to be going up on the right. That's how it means. Falls to the left of the graph and rises to the right. But then you also have the other part. If your leading coefficient is negative, that's you, then the graph rises to the left and falls to the right. So the graph of this one would be it rises to the left, but then it falls to the right. So your graph would look like this. Now, keep in mind, if your exponent is odd starts with an O, your graphs are going to go in opposite direction. One's going to go up, one's going to go down. One's going to fall, one's going to rise. Now, how do you keep in mind which one is positive and which one is negative? Well, if it is positive, you think of negative things or positive things? Positive, right? Up or down? Up. At the very end, it goes up. If we're talking about negative, at the very end, you go where? Down. So that's the way you could kind of think about it, like, oh my God, which way does this start? Well, you don't know how it starts, but you know how it ends. If you hang out with negative people, you're going to become a negative Nancy. So stay away from them.
Or you make them positive.
But if you hang out with positive people, so if those negative people are hanging out with you, you are positive, more than likely you'll make them positive peeps. The other scenario is if you're n, which is your exponent, and right now we're going to do examples and you're going to see it a little bit better, is even. So now we're going to cover the other option. If your n is even, and if, and we're going to have two scenarios like over here, 1 and 2, your leading coefficient is positive, then the graph rises to the left, rises to the right. So if your leading coefficient is positive, then the graph rises to the left and rises to the right. Now, what does that mean? Let me give you two quick examples. Boop, a parabola. Or sometimes you will have something that looks like a W. But at the very end, they both go which way? So positive goes up, goes up, goes up, goes up. Both go up. They both go in the same direction. If your leading coefficient is negative, where do you think they're both going to go? Down. They're both going to fall. Then the graph falls to the left and also falls to the right. So when we're talking about that, we're talking about a negative parabola, negative quadratic, so they both go down. So if it's negative, it goes down. Are we okay with that so far? Okay, so for example number 2. So example number 2 is what is the end behavior? And it has to do with everything we just wrote down. What is the end behavior? So we're going to get 3 examples just so we can see what the difference is. So the first one is y equals 2x to the 5th plus 3x squared minus 2. Is everything in order? Yes. So we look at it, and we're going to look at the exponent, at the degree. Is your degree odd or even? Odd. Your degree, right? So my degree is 5. 5 is odd. So when I look at it, perfect. I'm dealing with the top section of what I wrote, with this part up here, right? So it is odd. Now, is your leading coefficient a positive or a negative? Positive. So when I go here, and let me just do it a different color. And I'm going to erase it right now, but you're telling me it is odd and it is positive. So what is my answer going to be? That would be your answer. And as that's your answer choice. But you need to make sure you know. But you're going to have to learn to do it without your paper. So remember, odd means opposite. If I knew that it's positive, I know it's gonna rises to the right. So if it rises to the right, then it has to do what over here? Falls to the left. But for now, you have your notes until you start getting used to it. So it was odd and positive, right? Just in case. So falls to the left, rises to the right. Questions, questions, questions. So let's look at this next one. F of x equals negative 3x to the 5th minus 2x to the 6th. Plus 4. Are we ready to go, or we have to do something? We need to put it in order. So who's going to go first? 2x to the 6th minus 3x to the 5th plus 4. So when I look at this, is this odd or even? Even. So my 6 is an even because my degree is 6, so that is even. Is it positive or negative? Negative, because I have a what? A negative 2. Negative 2 and the 6. That's what I'm looking at right there. What did I look at over here? The positive 2 and that. So it's negative, it's even. When it's even, they both go the same way. Here, they're both going to go where? Down. So falls to the left and falls to the right. But remember, in case you're like, what in the world? Well, isn't that what this one says right here? That's what it says right there. It's even and negative. And the last one, just to be, okay, this one's different. That's right. Bump, bump, bump. Bump, bump, bump. And this one. All right, let's look at this. So this problem, because you are going to have one like this one. So I need to make sure everybody's ready to pay attention to the explanation for this one. In this problem, what would you have to do in order to do it the right way? Distribute what? What does x plus 4 to the 4th power mean? You have to write it how many times? 4 times. So imagine doing FOIL x plus 4 plus 4, and then x, whatever you get to another x plus 4, and then whatever you get from there to, it's going to be a lot of work. Now, this is a shortcut to it. Are you ready for it? What is your exponent for this one? 1, right? So it's going to erase more. No. So there's an exponent of 1 here. What's the exponent here? 1. And my exponent here is what? 4. What's 1 plus 1 plus 4? At the very end, I'm going to end up with a degree of 6. Because when I do FOIL between two of them, what's the biggest degree I get? X squared. Because what's 1 plus 1? 2. So I add these degrees, 1, 1, and 4, and I get 6. Now, how can I know if my leading coefficient is going to be positive or negative? It's going to be positive because look at x. Is this x positive or negative? Is this x positive or negative? Is this x positive or negative? So it's going to be positive. So it's a positive even or even positive. So what's my answer going to be? Very good. Rises to the left and rises to the right. Both of those. Now, this plus all the notes above, bless you, it is for questions 3 and 4 of your worksheet. There's no notes before we get to example 3, so we're moving on. So for example number 3, and here we're gonna find the zeros and I don't know why I put then. It should be and their multiplicity. And their multiplicity. When you hear the word multiplicity, what do you think of? Multiplication. And multiplication means how many times it what? It multiplies or it happens. So we're trying to see how many times does each of these happens. Okay? Now, we have already worked on finding zeros. Because in order to find zeros, you need to be able to factor. So let's say this is the first problem you get. And I think one of them will be like this. We'll find out. This is going to be for 5 and 6 on your worksheet. So when I look at this problem, I have 4 terms. So when you have 4 terms, how do you factor this out? By what? Grouping. By grouping, right? So let's look at this. So for the first 2 parentheses, what can I factor out? X squared. Perfect. So this becomes x squared parentheses. What's left over?
1 and 7.
Oh, I think I did something wrong. Sorry. This is supposed to be a 3. This is supposed to be, and it's still x squared, but that was supposed to be x cubed at the very beginning, x cubed minus 7x squared. So when I factor out an x squared from x cubed, this becomes x minus 7. Very good. Negative 4x plus 28. They're both divisible by negative 4. And this becomes x minus 7. So I have x minus 7 and x squared minus 4. Am I done factoring? No. What's next? The difference of perfect squares, right? So this becomes x plus 2 and x minus 2. Now, we've learned factoring. Then after factoring, we did a lesson or a couple lessons after we did solving. Now we have to find the zeros or solutions. In order to do that, you have to set each one equal to 0. I don't know if you remember. So x plus 2 equals to 0, x minus 2 equals to 0. That's your job, to set them equal to 0. Once you set them equal to 0, you solve for x. What's the first one going to be? Positive 7, right? Because we do plus 7, x equals 7, minus 2, x equals negative 2, plus 2, x equals a positive 2. So your answers are going to be long. The good thing is in your worksheet, you don't have to write them out, but here you do. So I have 3 answers. So I have to put a 7 here, a negative 2 here, and a 2 here, because those are my 3 answers. Now, you found your 0. That was the first thing that your title of example 3 says. Find the 0. Now their multiplicity. In this case is, how many times is my answer 7? How many times is my answer negative 2? How many times is my answer 2? So all of these have a multiplicity, and I'm just going to abbreviate, of 1. Multiplicity of 1. Multiplicity of 1. In one of the other examples, we're going to cover some that have a multiplicity of a bigger number, not just 1, okay? Now, the next part is you need to know, is the graph going to touch the x-axis and turn around, or is it going to cross? And this is where you need your calculator. I don't have a calculator on the computer, so I can't show it to you, but please go on your calculator and graph this part, like the original problem. X cubed minus 7x squared. And I'm just going to do a little sketch of what's the graph is, what's happening here. I don't know. 1, 2, 3, 4, 5, 6, 7 at 2 and at negative 2. So when you graph it, what does it look like? So the question is it crossing the x-axis, or does it touch it and turn around? At negative 2, 2, and 7. So a touch would be, it comes here and it turns around, or is it actually at negative 2 going through it? Is it crossing, are they crossing the x-axis? Is it touching, turns around like this, or is it actually going through there? Can I see somebody's graph? So you have something probably like this. This is what you have, but of course it's crossing right. So is it crossing the x-axis, or is it touching and turning around? It crosses. It crosses. So all of these you would put crosses x-axis. Crosses x-axis, crosses x-axis. All of them cross the x-axis. Now, what do you notice about the multiplicity? It is what? What was the multiplicity of all those? 1. Is 1 an odd or even number? Odd. So keep that in mind. 1 is an odd number. Odd number crosses the x-axis. So your answer is going to look like this. It's going to have all this there.
This one is an even number. Like,
What's going to happen when it's an even number? I don't know. Let's look at the next problem. That's the whole point here. Let's look at B. So for B, let's say we get this. F of x equals 5 parentheses x squared plus 9 and x plus 6 squared. So let's look at this problem. Let's look at this problem. And I think one of your problems on your worksheet is going to be like this one. Now, is everything already factored out? No? So I could do something else or no? Is there a difference of squares?
yes. Oh,
Is there a difference of squares?
yes.
No. What's in between the x squared and the 9?
Fine.
It's a plus. So is there a difference of square? No. So everything's already factored out. This means 5. This means x squared plus 9. Now this means x plus 6 and x plus 6. What am I supposed to do once everything is factored out? Set each one equal to 0. If you have a question, please ask and stop me. So I set each one equal to 0, each factor, the 5, the x squared plus 9, the x plus 6, x plus 6. Why did I write it twice? Because you have a 2 right there, just in case you're wondering where the extra x plus 6 came from. Now, can 5 ever equal 0? So this is not happening. There's nothing there. You won't get an answer there. Now, how can I solve for x squared in this problem?
Square root of x is square root of 9.
Well, first we need to subtract 9. And now, how do you get rid of the square? The square root. My answer is going to be plus or minus 3i. Very good. Why is it a 3i? Because it has that negative. Now, 3i is what type of number? Imaginary. So guess what? That's not even going to be an answer that I could find on the graph. It won't. Now here I subtract 6, so x equals negative 6. Subtract 6, so x equals negative 6. Now, how many zeros did I get? 2, but they're both the same number. So when you have to write this out, you're just going to put negative 6, but a multiplicity of 2. Now, the last question is it touching and turning around, or does it cross? And this is where I need you to graph it on your paper. 1, 2, 3, 4, 5, 6, 7. At negative 6, is it crossing or is it touching and turning around? So those of you who have graphed it, what happens to it? Is it going through it or is it touching and turning around? It touches here and it turns around. And you can hardly see where it touches, but it does touch and it turns around. So touches the x-axis and turns around. Now, your multiplicity here is what kind of number? Even. So, shortcut to this where you should not need a calculator is if your multiplicity is odd, it's going to cross. If your multiplicity is even, it's going to touch and turn around. I'm not writing it down. Hopefully you remember it, or you write it down on your own.
Just odd and cross.
If it's odd, it's going to cross. If it's even, it's going to touch and turn around. Alrighty, so are you ready to do one on your own? F of x equals 4x minus 3 squared and x plus 6. And don't stay there daydreaming. Get to work right away, please. So look at that one. Is it already factored out? You know, it's already factored out. I just need to probably write out some of them. Probably just have to write out some of them.
Let's see.
I have a book like that.
Come on, write it out. Write it out. And so once again, this is going to be for problems 5 and 6. 5 and 6. Come on, come on. So I'm hoping you already did this. By the way, I got an email from your counselor, Ms. Robles, saying November 14th is the last day for you to drop the class. If you think you're going to fail, if you think you need to get out, we need to talk about it and make a decision. What is the multiplicity of one answer going to be?
2,
And the other one's going to be?
3.
So keep in mind, it deals with your exponents. That's really what where it comes from. This is nope. This is a 3. This is a 3. This is a -6. This is a -6. And this is a -6. So my only two answers, 3, -6. Multiplicity of, I don't know. Multiplicity of, I don't know. And then specify, does it touch and turn around or does it cross, depending on the number? So go ahead and finish it off. Example number 4 is a piece of cake. Ouch. So 3 is there twice, so multiplicity of 2 and a multiplicity of 3. So 2 is even. Even means it what? Touches and turns around. Touches x-axis and turns around. And odd means it crosses x-axis. So once again, this is her problem 5 and 6. Alrighty, are we good? Yes? So the next part, it's one of the easiest, and it's going to be for problems 7 and 8. Turning points. How many times is your graph going to go from up to down, down to up, and stuff like that? And there is a shortcut to that, and it comes from part of the notes. Example number 4. the maximum number of turning points of a polynomial function is the degree, and we already talked about the degree, right? We said it was n minus 1. The degree minus 1. That's how it is. So for the first one, we're going to give you y equals 10x to the 5th plus 3x to the 4th minus 2x to the 3rd plus 1. So when you look at that and you determine your degree, in this case my degree is 5, and I have to do 5 minus 1, which equals 4. So there is 4, and I'm going to put TP, not for toilet paper, but for turning points. Simple? That's going to be an easy problem, right? Now B, just because it's going to be a little bit different. Let's say we had, and maybe I should put y equals x plus 3, x plus 3, x minus 4 squared, and yeah, we'll stop there. So here, remember, what was the easiest way for you to find your degree? It was example 1, number 2, letter C. Do you actually have to multiply like crazy?
No.
What is your exponent here? Exponent here? So my degree for this one is what? 4 minus 1. My answer will be 3. 3 turning points. This is for problem 7 and 8. 7 and 8. I need to... All right. So once again, problems 9 through 12, they're just graphs. Maybe just looking at the equation, it helps you like determine, you know, which one's your graph is going to be, like if it's going to open up or down, what's going to happen there. So that kind of helps if you could find those shortcuts. But the last example, example number 5. That's how you missed right there, so leave a couple of lines. So for example number 5, it says use the that's an intermediate value theorem to determine if the function has a real zero. Okay, so let's see if it has a real zero between integers. Now, how do we do this? One answer has to be positive. And one answer has to be negative. It sounds more complicated than what it is. And all that writing to me, ugh. But right now when we do the problem, you're going to see it's like, okay, it's not as bad as it sounds. So they're going to give you a function. 2x to the 4th minus 4x squared plus 1. And they're going to tell you between, and that's what B/T stands, between -1 and 0, can you tell me if there is a real 0? So all you have to do is replace every x with a -1, get an answer. Every x with a 0 and get an answer. If one answer is positive, one answer is negative, then your answer is yes. So for example, we're going to take this to replace every x with a -1 first. So if I replace this with a -1 and this with a -1. Okay, so that's the first thing we're doing. Now, what is -1 to the 4th power going to be? Does it end up being positive or negative? Positive, right? So this is just going to become 2 times a +1 minus 4, and that -1 squared also becomes what? Positive. So we end up with this. Now, 2 times 1 is 2. -4 times 1?
4.
-4 plus 1. What kind of answer do I end up with here? A -1, right? So, okay, I have a -1 answer. That's fine. But now I have to go back and now plug in a 0. So now I'm going to try it with a 0. 0 to the 4th power? 0 times 2? 0. This also becomes a 0 plus 1. This answer becomes a 1. So here's one answer, here's one answer. Is one a negative and one a positive? Yes. So your answer, the way it's going to look, it's going to say yes. Well, at the very end, it'll say yes. But it'll kind of say f of -1, because when I plug in the -1, I got a -1. F of 0, when I plugged in the 0, what did I get? 1. And then it's going to say yes. This is the way it's going to look. So when you plug in this -1, you got a -1. When I plugged in the zeros in here, I got a 1. So when I plugged in the 0, I got a 1. So let's try one more, and that's going to be it. So for B, f of x equals x cubed plus x squared minus 2x. Now, they're going to give you different numbers. This one's going to say between -3 and 2. -2, sorry. So they would give you specific numbers for you to use. And this one is going to be a -3 and a -2. So go ahead and try to do that one. Remember, first you plug in a -3, get an answer. Then plug in a -2, get an answer. If one's positive, one's negative, then it's a yes right away. -3 to the 3rd. What is that? -27. -3 to the 2nd. It's a +9 plus 6. So this ends up being -12. Okay. So f of -3 gave me a -12. Now when I do the -2, -2 to the 3rd is -8 plus 4 plus 4, which gives me 0. So f of -2 is 0. Now 0, it's neither a positive or negative, but it's definitely not a negative number. So 0 here will be considered as positive. Is 1 negative and 1 positive? Yes. So then the answer would be yes, there is 0, 0. This is just for number 12. Okay? So let me give you your worksheets or your packet more than anything.